Kushak, just first of all, define yourself, and give you a brief intro about yourself.
Right, sir. Good morning, sir. My name is Kushak Vashisht. I belong to a place called Jaisalmer, which is in the westernmost part of Rajasthan. I did my graduation from Government Engineering College, Ajmer, in mechanical engineering. During my graduation, I did a summer internship in warehouse management with inbound operation. My final year project involved desiccant material, evaporative cooling with desiccant material. And in my college time, I participated in lot of in cultural activities and in sports event. As I believe that I'm good at, as I like to dance, and I think I do well in sport. My hobby includes spending time with my close ones, and I am a self-motivated person looking for exciting career opportunity in energy sector and willing to contribute towards India's energy future by being a part of HPCL.
Okay. So have you completed your M.Tech or are pursuing M.Tech?
No, sir. I've done my graduation in 2021, and ever since then, I've been preparing for PSU exams, sir.
Okay.
Right.
So Kushak, just tell me why we use the theory of failures.
Sir, because as a in hope that our material or any mechanical operation doesn't fail, and we have a clear anticipation that this particular machine is going to last till this long. So it is a security measure that we take, sir.
Okay, can you just tell me why we use the factor of safety?
Sir, on the same grounds as theory of failure, we use it so as to give us a pre-indication that this particular, let's say, material is going to fail at this particular point of time. So we, if we have as a threshold, we take the failure stress and we keep the stresses on that material below that, so that the material does not fail. So it provides that benchmark factor of safety, sir.
Can we find out the stress directly?
Not directly, sir. I'm not aware whether we can find it directly or not, but my UTM machine tells us the stresses, sir. Generally, it is the UTM machine is used to find out the stresses, sir.
Okay. Which parameter we are just going to find out by the UTM?
Sir, the tensile strength or the compressive strength, both we can find out from UTM.
Why we use the Isodan Charpy test? You know about
Sir,
that, this test?
Right, sir. I do know about that.
What is that?
Sir, sir, can I take a minute?
Yeah, you can.
Sir, Charpy in particular tells us the transition, the brittle to tensile to brittle transition that shows Charpy test, and both of them in particular are impact tests, sir, that we try to that we perform, sir.
Is there any particular reason? So we are just doing the Isodan Charpy test. Sir, what are the properties we are going to find out by that? Any idea?
Sir, I'm not aware of that. I just know that both of them are impact tests that we carry out on material, sir, so that we know that the toughness and properties like toughness, resilience, we can calculate or have a.
What is toughness?
Sir, the ability of material to store energy until it breaks, till the fracture point. That is called toughness, sir.
Or resilience?
Sir, resilience is the amount of energy the amount of strain energy that is stored in a material within elastic limits, sir.
Proof resilience?
So proof resilience is the maximum amount of resilience, which in turn applies that it is the resilience at the elastic limit, sir.
Modulus of resilience?
Pardon me, sir. Your voice.
Modulus of resilience?
Sir, modulus of resilience is resilience only per unit volume or strain energy per unit volume, sir.
Can you just find out how to find out the strain energy in the case of a beam is subjected to a movement at their fixed free end? If a cantilever beam subjected to a movement at their free end, so how can we just find out the strain energy?
Pardon me, sir. Your voice got break. How can we calculate, sir?
Strain energy in the case of a cantilever beam subjected to a movement at their free end.
Yes, sir. There are different methods to find the strain energy. we can also calculate. It is also strain energy in mathematical terms is the product of the force in the deflection, half into force into deflection, the stress into deflection, sir. So we can calculate that, and there are strain energy theorem as well, so we can apply that on cantilever beam as well to calculate it, sir.
What's the formula?
Sir, it's P square, which is load in times L over 2 AE.
For
If
which
there is
strain
if there
energy?
is
AE. It is
Yes,
subjected
sir.
to a movement, and you just take the 1 upon AE something. Have you
No, sir.
confirmed?
No, sir. If there is a point load acting, sir, if there is a movement,
I'm just
then
talking about the movement, na?
right, sir. Right, sir. Pardon me, sir. I beg your pardon. It's, sir, P square L over 2 GE, sir. Shear modulus.
Okay.
Sir, yes, sir.
Why we use the Mohr circle?
Sir, it is the diametrical or illustration of the principal forces, or the number of forces in may it be direct shear or direct tensile forces or shear forces on a body. So it is used to represent it on a diagram, sir. We use Mohr circle.
What's a Mohr circle for a fluid at rest?
Sir, that is a point on the positive x direction, as the molecule is subjected to direct tensile forces in every direction, sir.
It's positive x-axis. Is this
Positive
confirmed?
right, sir. I'm sure, sir.
Okay. So, what do you mean by principal stress?
Sir, the plane. There is a plane in a body which is called principal plane, and the forces acting on that plane is called principal stresses, sir.
What is the difference between the in-plane Tomax and absolute Tomax?
Sir, I haven't read about it, sir. I'll go back and read about it, sir. I'm not able to recall it.
What do you mean by bulk modulus?
Sir, bulk modulus is the ratio of direct stress over volumetric strain, sir.
Direct stress. What type of direct stress we are taking in this case? Is there any special condition or normal?
Sir, as far as my memory concerns, sir, I think it is tensile stress, but I'll go back and look into it, sir.
Okay. What do you mean by Poisson's ratio?
Poisson's ratio, sir.
Mm-hmm.
Sir, it is the ratio of lateral strain over longitudinal strain, and its value ranges from -1 to 1/2.
For which it's -1?
Sir, I've read about it, but sir, I'm not able to recall it right now, sir.
What's the range for the engineering material?
Pardon me, sir. What did you say?
What's the range for the engineering materials?
Sir, for engineering materials is somewhere close to 0 to 1.5, 0.0 to 0.5, sir.
Okay, Kushagra, I will just give you some feedback about your interview. Overall, you are a good. There is no issue. You have a good confidence, and you will give the answer in a proper way.
Right, sir.
So there is no issue.
Right,
But
sir.
little bit, I think so. Okay, you are just require some revision of the subjects also. Right?
Okay, sir.
One time, see when you just going to be revise the subjects, and this will be surely clear. All doubts are going to be clear. Okay.
Thank you, sir. Thank you so much. Anything else, sir?
No. There is no issue.
सर है ना, मैं आपसे 2-3 क्वेश्चन पूछ लूं सर, फटाफट.
You can ask.
सर, एक तो टॉम थ्योरी ऑफ मशीन और मशीन डिजाइन का भी सर, क्योंकि उसके अंदर आपके उसमें डिस्क्रिप्शन में लिखा हुआ है कि सर मशीन डिजाइन और सॉम की है, तो सर यही दोनों पढ़ना एचपीसीएल के लिए वो रहेगा कि मेरे को टॉम भी पढ़नी पड़ेगी?
नहीं देखो, एटलीस्ट 3-4 सब्जेक्ट जैसे एचपीसीएल की बात करें ना, जितने ये पीएसयू होते हैं एक्सेप्ट द रिसर्च सेंटर, जैसे कि बार्क, ISRO, DRDO, इनके अलावा जिसमें जो ये रहता है ना, इनके मतलब फायर राउंड टाइप क्वेश्चंस रहते हैं. दे कैन आस्क फ्रॉम एनीवेयर एल्स.
ओके सर.
जनरली 4-5 सब्जेक्ट प्रिपेयर होते हैं तो प्रोबेबिलिटी अच्छी हो जाती है कि आप मैक्सिमम क्वेश्चन के आंसर दे पाओगे.
ओके सर.
दे विल नॉट आस्क टू यू अकॉर्डिंग टू द रिसर्च पॉइंट ऑफ व्यू. दे आर जस्ट आस्किंग टू जस्ट लाइक अ फायर राउंड्स. ये क्वेश्चन पूछा, डायरेक्टली क्वेश्चन वो ज्यादातर वैसे ही पूछते हैं जो सिंपल होते हैं, बहुत ज्यादा डीप में नहीं जाते। तो
ओके
मोर
सर।
देन वन सब्जेक्ट आपके प्रिपेयर होने चाहिए, एटलीस्ट 4 to 5 सब्जेक्ट यू हैव टू प्रिपेयर फॉर द इंटरव्यू।
सर
सो
मेरे
व्हाटएवर
20 फर्स्ट
दे
को,
यू कैन जस्ट डिसाइड अबाउट योरसेल्फ, है
ठीक
ना।
है सर, मेरा पेपर थोड़ा लेट है तो सर मैं सोच रहा हूँ मैं पढ़ लूंगा, तो मेरे को कोई दिक्कत नहीं, मेरे पास टाइम है सर, तो मैं कर
टाइम में देन
लेता
यू
हूँ
कैन
सर।
प्रिपेयर,
ओके सर। सर
है
दूसरा बात ये थी कि सर मैंने जब आपसे पहला ये लिया था ना इंटरव्यू, तब आपने मेरे को एक फीडबैक दिया था कि मैं एक्सप्लेन बहुत ज्यादा कर रहा हूँ, तो सर
ना।
मेरा जो आंसर्स हुए हैं वो थोड़े क्रिस्प हुए हैं कि मैं इनको और थोड़ा
नहीं,
छोटा करूँ?
टुडे इज गुड, देयर इज नो इशू।
ओके सर। और सर एक लास्ट चीज है सर, ये थोड़ा विदाउट इससे रिलेटेड है, मुझे सर विजेंद्र सर के नंबर नहीं मिल रहे, तो अगर आपके पास हो तो आप दे दीजिए सर।
बेटा उनका पर्सनल नंबर तो मेरे पास भी नहीं, क्योंकि वो हैदराबाद में रहते हैं। मेरी बात नहीं, एक
अंडरस्टूड
बार
सर।
मुस्कान मैम वगैरह है ना,
अंडरस्टूड
वो
सर।
आपको दे देंगी, जिन पे वो
जी
जनरली
सर।
बात करते हैं। यू कैन
जी
जस्ट टॉक
सर।
टू, है ना,
जी सर।
मुस्कान मैम से आप बात कर रहे हैं एक
ऑल राइट सर।
बार। थैंक यू सो मच।
थैंक यू सो मच सर, हैव अ नाइस डे सर।
ओके, सेम टू यू।